Ever plug something in and kind of wonder, like, how does this actually work?
Right.
We're going to crack open those mysteries today.
Yeah.
Electricity.
Yeah.
Going beyond just flipping a switch
Absolutely.
to understanding the invisible forces that power, like, basically everything in our lives.
Yeah, and you might be surprised how relevant this all is.
Mm-hmm.
Even if your last science class was a while back, let's just say that.
Okay, fair enough.
We're talking light bulbs, doorbells,
Okay.
even the potential for building your own electromagnet.
Whoa, hold on. We're going to get to that.
Yeah,
But let's unpack this whole thing, starting with the fundamentals.
sure.
Our deep dive today is fueled by this section from a science textbook we found,
Okay.
Electric Current and Its Effects.
Oh.
Catchy title.
I like it.
And it kicks off by introducing us to this, like, language of circuits.
Yeah.
It's kind of like you can't build a house without understanding blueprints.
Right.
Electric symbols. Those are our blueprints.
Precisely. They're the key. These symbols, they represent the different components
Okay.
of a circuit, like your batteries, your bulbs, switches, you name it.
So, like, once I learn these symbols,
Yeah.
I can, like, read a circuit diagram.
Exactly.
Got it.
Yeah, it's kind of like learning the alphabet
Okay.
before you can read a book, you know?
Okay.
Got to get those fundamentals down.
So basically, like, learning a new language
Mm-hmm.
opens up a whole world of communication.
Absolutely.
Learning these symbols unlocks this deep understanding of how electricity powers everything around us. Yeah.
Exactly. For example, take the
Here we go.
the Humble battery.
Okay.
We all use them every day.
Sure.
But how many of us actually understand like what's going on inside those little cylindrical cases?
Yeah, it's not just about, like, cramming a bunch of double A's
Exactly.
into a toy and crossing your fingers.
That's right. It's all about how those individual cells are connected.
Okay.
They need to be linked in a specific way, positive to negative, to create a flow, right, of electrical current.
And so it's not just, like, throwing batteries in there all willy-nilly.
You know, there's a method to the
There's a
madness.
system.
It's like forming, imagine like a human chain
Okay.
where
Great.
everyone has to hold, you know,
Right hand, left hand.
the right hand of one person and the left hand of another.
Okay, I like that visual.
Yeah.
So by connecting these multiple cells in this, like, plus to minus pattern,
Yes,
we create a battery.
that's right.
And, like, the more cells we add,
Yes.
the greater the voltage.
More power.
More power. Got it.
Yeah, it's like adding more links to that human chain.
Okay.
The longer the chain, the
Yeah.
stronger the force it can generate.
Okay, so that's why,
Yes.
like, a handful of those tiny button cells
Right.
can power a watch, but, like,
But you need
you need a car battery,
a car battery.
which is, like, way bigger
Oh, yeah.
to get an engine going.
It's all about scale.
Okay, so we've got these electrical symbols down.
Yes.
We've built our battery.
We're ready to go.
Time to, as they say, you know,
Flip the switch.
flip the switch.
Yeah.
See what happens. Although,
Yeah.
gotta be honest, I always get a little nervous
Oh,
around live wires.
And for good reason.
Right.
Electricity is powerful stuff. You know what I mean?
Yeah.
Got to be careful.
So this leads us to our next point.
Yeah.
The sometimes overlooked fact that the flow of electricity
Yeah.
generates heat.
Heat. Yeah, absolutely.
Okay, so this is what the textbook calls
Let's hear it.
the heating effect of electric current.
Ooh.
Sounds a little intimidating.
A little bit. Yeah. Like something out of Frankenstein's lab.
Right, like crackling, zapping.
A little bit dangerous.
Yeah.
But also really important because
Okay.
it's the reason why we have so many essential appliances.
Okay.
Think about it. Toasters, ovens, even those like cozy electric heaters
Yeah.
on a chilly night.
Sure.
They all harness the heat generated by electricity.
Oh, that seems so obvious now that you say it.
Oh.
But, like, I guess we just don't think about it.
It's easy to forget.
Even a simple light bulb,
Yeah.
it gets hot when it's on
Exactly.
because of this effect.
That's right. That's right.
So it's like the wire is resisting
It's pushing back a little bit.
the flow.
Yeah, yeah.
And that resistance
Yeah.
causes it to heat up.
It's like friction almost.
Friction. Okay.
Yeah.
So, like, the amount of heat
Yeah.
depends on, like, the type of wire.
The type of wire, how thick it is, how long it is.
So that's why
Pace factor.
different appliances use different types of wires.
That's right.
Okay.
They got to be designed to handle
Yeah.
specific amounts of current and heat.
So when we talk about things like energy efficiency,
Yeah.
especially with light bulbs,
Right.
we're really talking about minimizing the, like, unwanted heat
Absolutely. You want to get rid of that?
and maximizing that light output.
Exactly. That's the goal.
Right.
You've hit the nail on the head.
I-
And that's where the whole conversation about those old incandescent bulbs
Yeah.
versus the LEDs comes in.
Right.
Remember the textbook mentioned how those old incandescent bulbs
Right.
are not very efficient.
Oh, yeah. Those old school bulbs, they always seem to burn out right when you need them most.
Exactly. And a big part of that is because they're so inefficient.
Okay.
They're losing all this energy to heat because of that whole resistance heating of the filament we were talking about.
So they're basically like little space heaters that also happen to give off some light?
Pretty much. Now, LEDs, on the other hand, those are way more efficient.
Yeah.
And it's not just about them lasting longer,
Mhm.
though that's definitely a nice bonus. It's about how they actually produce light.
Okay, fill me in, because I'll admit I'm a little fuzzy on the science behind LEDs.
All right, so imagine this. Instead of needing to heat up a filament to produce light, LEDs, use a process called electroluminescence.
Okay.
It's a mouthful.
Yeah, it's a big word.
But it basically means they can convert electricity into light directly. Okay. Using this special type of material called a semiconductor.
So instead of like taking a detour through Heat Town,
Right.
LEDs are like the express train to Light City.
You got it. And because they don't waste as much energy on heat,
Hmm.
they're way more efficient overall.
Okay.
Less wasted energy means lower electricity bills,
Right.
less strain on the environment. Everyone's happy.
So LEDs really are the cool kids on the block,
They are.
literally and figuratively.
But you know what I find even cooler is that this whole discussion about heat,
Yeah.
this is really just the tip of the iceberg.
Um,
When it comes to the effects of electricity,
okay, there's more.
there's more.
We've got heat, we've got light.
Mhm.
What else can this invisible force do?
Get ready for this because things are about to get magnetic.
Hold on. I mean, literally.
Wait, electricity can create magnetism.
It's true.
I think I missed that chapter in the textbook.
Well, it's all connected. And remember that experiment you mentioned earlier, the one with the compass and the live wire? Oh, yeah, the one where the compass needle went all wonky
High wire.
when they turned the current on?
Exactly.
It was like magic.
It was like magic.
But like science magic, I guess.
Exactly. But it's not magic.
Okay.
It's science. And that experiment,
Okay.
it perfectly illustrates what we call the magnetic effect
Okay.
of electric current.
So when electricity flows through a wire,
Yes.
it creates a magnetic field.
Around it, yeah, it's surrounded by this invisible force.
And that's strong enough to like move a compass needle.
strong enough to influence it, yeah, for sure.
Okay. That's pretty mind-blowing.
Yeah.
But is this magnetic effect just like a cool science trick?
Right.
Or does it like have any practical uses?
Oh, it's way more than just a trick.
Okay.
This is the principle behind so many technologies
Really?
we use every day. Yeah, think about those massive electromagnets.
Okay.
They use in scrap yards to lift and move cars.
No way. Those,
Giant
yeah, those huge
metal monsters are powered by the same force.
The same basic principle. That makes a compass needle twitch.
That's right. And the textbook goes a step further.
Okay.
It actually explains how we can harness this power ourselves
Oh,
to build our own electromagnets.
wait, hold on. I can build my own scrapyard monster. Sign me up.
Maybe we should leave the heavy lifting to the pros for now.
Right. Okay. Maybe starting a little smaller.
Yeah, car crushing is probably not
Not a good hobby to pick up.
for beginners anyway,
Okay.
but the basic principle is actually pretty straightforward.
Okay.
To create an electromagnet,
Hmm.
you essentially coil a wire,
Right.
and then when you pass an electric current through it, that coiled wire becomes magnetized.
So it's like the wire transforms into a temporary magnet.
Yeah, and it's all thanks to the electricity flowing through it.
And here's where it gets interesting. So you can control how strong this magnet is.
Exactly. You've got your finger on the pulse here.
So the more coils you have,
Yes, more coils, stronger magnet.
and then the more current you push through.
Absolutely. More
Shit.
power, more magnetism. It's all connected.
So like in theory, if I had enough wire,
Yeah.
enough batteries,
Okay.
and enough time,
All right, let's hear it.
I could build an electromagnet strong enough to, come on, I don't know, lift a refrigerator.
Okay, now let's not get carried away.
Okay.
Building a safe and powerful electromagnet
Right.
requires a bit more than just a mountain of batteries and like a roll of wire, you know?
Okay. All right. So no fridge lifting for me today.
Not today.
But like just knowing that I could
What?
theoretically create this invisible force.
Exactly. It's pretty amazing.
It's like having a superpower.
It is a bit like having a superpower, isn't it? And speaking of everyday superpowers,
Okay.
have you ever actually thought about how a simple doorbell works?
You press the button,
Yeah,
a bell rings,
right.
you get led into the house.
Simple, right.
Case closed.
But behind that seemingly simple action
Yeah.
is a really clever application of the same electromagnetism we've been talking about.
Right.
Remember how we were saying an electromagnet can be turned on and off
Yeah.
by controlling the flow of electricity?
Like a light switch, but for magnets.
Exactly. Well, a doorbell uses a rapidly switching electromagnet
Okay.
to create that signature dimmeling sound.
Wait, seriously.
Seriously.
Break it down for me. How does an electromagnet make a bell ring?
All right, so picture this. When you press the doorbell button,
Mm-hmm.
you're completing an electrical circuit.
Gotcha.
This allows a current to flow through a wire that's coiled around a piece of iron,
Right.
turning it into an electromagnet.
So the coiled wire becomes a magnet
Exactly.
because of the electricity.
That's right.
And then what?
Well, that newly formed electromagnet
Okay.
attracts a metal arm that's positioned near the bell.
So the magnet pulls the arm towards it,
And
right?
here's the genius part.
Okay.
When that arm is pulled toward the electromagnet,
Yeah.
it hits the bell, making that ding sound.
Okay.
But at the same time, it also breaks the electrical circuit.
Wait, so by hitting the bell, it turns the magnet off.
You got it.
And
The current stops flowing, the
Yeah.
electromagnet loses its power,
Right.
and the metal arm springs back to its original position.
Okay.
But as soon as it springs back,
Yeah.
it completes the circuit again.
Okay.
The electromagnet turns back on,
Gotcha.
and the whole cycle repeats itself.
So it's like this whole back and forth,
Exactly. It's a rapid dance.
creating the dingling.
The dingling that we all know and love, it's amazing.
Wow. That is surprisingly clever. It's like this perfectly timed dance
It is. It's like a little choreography.
of electricity,
Magnetism.
magnetism, and like
All these different forces working together
mechanical engineering
to create something.
just to make a doorbell ring.
The things we take for granted, right?
It really makes you appreciate like the ingenuity
Yeah, absolutely.
that goes into designing the world around us.
It's really quite remarkable. And this is just scratching the surface
Oh no.
when it comes to the wonders of electricity, you know?
There's more.
There's a whole universe
Come on.
of fascinating applications and discoveries out there just waiting to be explored. You know, it's an exciting field to be in.
You know, it's funny. We've talked about heat. We've talked about magnetism.
Right.
But like through it all,
Yeah.
we've been using electricity to like illuminate this whole conversation.
Literally.
Literally, right?
Yeah.
It makes me wonder, like, what exactly is going on inside a light bulb?
That's a great question.
Is light just another side effect of electricity, like heat?
It's a question that's fascinated people for centuries.
Right.
And you're right to point out the connection with heat.
Okay.
Because as we saw with those incandescent bulbs, a lot of their energy is actually wasted as heat,
Right.
with light being kind of a byproduct.
Right. Those old school bulbs, like they get so hot.
Yeah.
So the light they produce is just a result of the filament.
Well, basically, the filament's getting so hot
Yeah.
from the electricity flowing through it
Yeah.
that it starts to glow. But with other types of light bulbs, like those energy-efficient LEDs we talked about,
Right.
the process is totally different.
Yeah. LEDs seem almost magical
Right.
in how little heat they produce.
It's pretty remarkable.
So how do they skip that whole like getting hot enough to glow step?
LEDs rely on this fascinating phenomenon called electroluminescence.
Okay.
And I know that's a mouthful,
Yeah.
but imagine this. Instead of needing heat, LEDs have this special material inside them
Okay.
that directly converts electrical energy into light energy.
So no burning filaments.
No burning filaments.
No wasted heat.
Very little wasted heat.
Just pure, efficient light.
It's really quite remarkable.
From excited atoms, it sounds like something out of a science fiction novel.
It does, doesn't it?
It's like we've unlocked a new level of light.
We're manipulating these tiny particles
Yeah.
to create light in a whole new way.
This whole deep dive has been, to say the least,
I know, right?
electrifying.
It's been a wild
We've
ride.
decoded the language of circuits.
We've explored the power of batteries.
We felt the heat of resistance.
Witnessed the magic of electromagnetism.
We even peered into the very essence of light itself.
And we're just getting started.
The best part is, there's so much more to learn.
Absolutely.
Thank you for tuning in to this electrifying adventure, everybody.
Yeah. Thanks for listening.
Until next time, stay curious.